Hi, I am Arpit Jain, and for this challenge, I built an AI Production Support Copilot. What is the problem? One of the recurring problem in engineering organization is the product incident management. Support and engineering team spend a significant amount of time manually triaging incidents, reading logs, identifying probable root cause, and routing tickets to the correct team. Why this solution matters? As system scale, this becomes increasingly difficult because operational complexity grows much faster than the team size. The often result is slow incident resolution, higher downtime on the production, and operational inefficiencies, as well as the cost is another barrier. What's the solution I'm going to propose? To address that, I designed an AI powered operational intelligence platform that helps automate production incident analysis. The platform accepts incidents and the logs, use AI to analyze operation failure, classify severity, identify probable root cause, assign responsible team, and it also recommended some recommendations to resolve that particular problem. What's the scope of decision? So I intentionally focus more on the backend side, like the backend architecture using in C#.NET Core, AI orchestration, and the system design, rather than the investing my time heavily to design front end looks like a good front end. Instead of that, I work purely on the backend side to just demonstrate how the backend architecture will work and how this all uh, production failure we can analyze, because I wanted to prioritize engineering depth and the operational workflow instead of some fancy front end polish work. I'll first show you a quick demo and then I'll walk through the architecture and the engineering decision. So I already have the project running on my system. I use .NET Core 8 along with the Swagger, which is for expose the REST APIs. So as you see, I have opened the Swagger page. On that Swagger page, we are able to see some of the APIs. The first one is the health API to determine whether the system is up and running. Then we have open post API to basically create an incident. And then we have to get API, one to get all the incident, and the another is to get a specific incident by the ID. So let's start with the first one, the post the incident. So as you see, that particular API requires three input parameters: the title, the description, and the logs. So let me update the. So here I taken a simple example of the payment failure, where user tried to complete the transactions, but due to some SQL exception, it got failed. So here we put the title like the payment checkout failures, a description, a brief description, and the logs. As of now, for the demo perspective, I use a simple log, but we can put the detailed log here as well. As soon as I hit the execution button, the request is submitted. The application ostracize the an AI workflow. That AI workflow basically analyze the incident context and return the structured operational insights. What it returns? It returns few of the major output fields, which is like severity, the root cause, the assigned team, and the recommended steps. So as you see, I input this particular errors in the system. AI analyze it and it returns me this particular thing, because it's related to the payment. That's why AI put the severity as high, because it's related to the payment. AI automatically assign this to the payment team. It mentioned what could be the root cause of this failure, and it also recommended some of the steps to get resolve that particular problem. One thing I specifically optimized for was structured AI responses. So the system request is strict to the JSON format only. It always return the JSON output from the model to simplify the parsing and the downstream the processing flow. So we will want track, or we want need to do any additional parsing or simplifying the output to get the desired variables. So we will keep it as a JSON only. Now let's go to another API. Let's hit this particular API to get all the incidents. So all the incidents are persisted into the SQLite database as of now using the entity framework core behind a repository abstraction. As you see, as soon as I hit that execute button, it will get all the incident which I created for the testing purpose, or the one which I created just now. It returns all these details. uh, okay, the next part, which is kind of more important for us, is regarding to the edge cases. Like, I have also added a validation and the centralized exception handling to ensure that the API behavior is consistent and predictable, and any invalid or malformed request, it get rejected. So we are in this particular challenge. I'd include that validation and centralized exception handling as well. So you see, I just put all the things as is empty here, and as soon as I hit the execute button, because the validation got failed, we got this error here. It contains the error, the type of the error, the title of the error, then the response code, and the trace ID, some of the required fill over here. Another thing, in case of accidentally we put some wrong open AI key, or the key which we created on the open AI get expired, that to handle this kind of exceptions, we already have that system in the place. So if something goes off from the AI end, it also shows us and give us the proper error through this mechanism. So that's all about the demo part. Now I'll walk you through the architecture part and some of the engineering decision behind this implementation. Okay, let me open the high level design diagram for this system. So as you see, I have already prepared this whole end to end workflow document. What we are doing, what current system is doing, what are the requirement, what are the technical challenges we are considering, what are the future perspective in case of scalability or reliability we want to do, how we can do it. So I have put all these details into this document. So let's start with the simple document, simple architecture design. Okay, so so as you see, we have few layers here, like API layer, then the application layer, then the domain layer, and so on. So I structured the system using the clean architecture principles to separate concerns and implementability. So each layer has its own work, has its own decision making system, and they won't interrupt each other. As you see, like the API layer, so the API layer is independent. It controls the it's we can say that it is a controller layer which handles the HTTP concerns, all the requests coming through. It handles all those HTTP requests, validate those requests, and then it calls the API station for the business logic. Then we have the application layer. The application layer basically is the main layer, or we can say it's the heart of the system. It contains the core workflow logic and the service abstraction, all the AI, like all the logic to handle those HTTP requests. The core logic, the business logic, are implemented in that application layer. Then we have a domain layer. So domain layer is basically as you know, like the domain layer is basically used to define the entities. So it contains all the business entities independently of infrastructure concerns. So to map them through the database tables, or any kind of model or entity we need to have, we will define into the domain layer. Then we have the infrastructure layer. Okay, what's that infrastructure layer? So the infrastructure layer is basically the layer where we are doing all the AI related stuff. It basically contains the integration like OpenAI, persistent systems, login, repositories, all these things. So, in this whole architecture design, one intentional design decision which I took is to isolate the AI provider behind the abstraction layer, so that the application could later support multiple LLM models, not only the OpenAI. If in future we want to go with another LLM model, we can easily integrate them without impacting any business logic. So, let's suppose in future, instead of OpenAI, we will want to use cloud AI, or we want to use Grok, or we want to use Gemini, then we don't need to go and change anything into the business layer. We just need to introduce those new LLM providers into the abstraction infrastructure layer, and we just need to map them to the business logic, and it all start working without impacting or without touching anything to the business logics. So that's kind of architecture level we are implementing. I have a detailed explanation into that document: what are the maintainability, what are the extensibility, how I test it, how the components are designed, what are the controllers, what controller used for what thing, DTOs, everything I have mentioned in the document. It's a brief document which contains each and every aspect of this challenge which I have created. Now let's go and quickly see some of the code, how I wrote the code here. So as you know, as you see here, I have opened that Visual Studio. In that Visual Studio, we have this uh, application. I have purposefully used the monolithic approach instead of the microservice approach, because I don't want to complex the challenge. Kind of For the complex, like, I don't want to add unnecessary things into that, so that it can. I just keep it simple, so we can achieve what we want to do. So in that, if you go, and as I mentioned, that in the infrastructure layer, we have all the AI related stuff, all the data related and data repository related stuff. So if you as you see, we have in infrastructure, we have a AI folder which basically use OpenAI service. We can integrate other LLM models as well. Here we have the data migration service, the FDB context, the repositories, everywhere, everything we are here. So that's the infrastructure layer, then the controller, then the domain. As I mentioned earlier, the domain contains all the entities, then the middleware. So that's the business layer basically, where we have the exception handling and everything else we taken care here. Uh, so let's open one of the file to see how the code is being written. So if you see OpenAI, so the code is pretty much use the all the standard industry standard flow of how to write a clean, scalable, sustainable, reliable code, which cannot have the duplicacy, redundancy, or kind of deadlock situation. So it's a clean, simple to code I have written. uh, the we can see few more classes if you want to. So let's go and see some of the repository classes, some of the exception handling classes. So you see, it all contains all the industry standard. There is no patches or something like which is not aligned with the industry standard or good code practices. So the incident service and everything goes here. So this is the services, this is the incident service, this is the business logic where we wrote everything, what how the that incident it gets stored into the database, and how we are going to involve the AI service and everything. We are basically all these logics are implemented here. So the insurance service act as an obstructure layer. It coordinates AI. It, as I mentioned, it coordinates with AI analysis and domain creations, and all the stuffs are here. The AI integration is intentionally isolated. As I mentioned earlier, I intentionally isolate AI services into this infrastructure layer, so we can couple we can avoid the coupling the application directly, and we can basically get rid of that hard-coded vendor-specific implementation. We can use whatever the vendor we want to use instead of OpenAI. If we want to use any other vendor, we can do it directly here. As you see in my solution, I also added the some of the unit test around the structure layer, because that's where the critical business behavior exists. Most external dependencies are mocked here. If you see, the external dependencies I mocked it here, to keep test isolated and deterministic. Okay, no, come to the another section where the trade-offs and the future improvements. So in terms of the trade-offs, what trade-offs we are basically uh, keeping here to create this particular challenge MVP. So for that rapid MVP delivery, I intentionally made a few trade-off. Like we use SQLite instead of the heavily used database like MySQL or SQL Server. I use SQLite instead of distributed database, because the focus of the challenge was architecture and the operational workflow rather than the infrastructure scaling. Like in this challenge, we are not something showing how we can scale the infrastructure. The core purpose of this challenge is to define how the architecture and the operational workflows works. So that's why I'll keep it SQLite as a database to keep it simple. Then the synchronous AI. Right now, the AI workflow is in synchronous behavior for a simplicity, but as at architecture level, the current architecture provide a possibility that we can easily involve it into the asynchronous event-driven pipeline as well. So it has that open ended integration that instead of synchronous, we can make the AI calls asynchronous as well, without making any much or changes in the code. And as I also mentioned earlier, like we are using monolithic architecture instead of the microservice architecture, and that too we use modular monolithic because it allows faster iterations while still maintaining the clean boundary between the layers. We don't want to heavy the system. Want to make the system heavy as of now for the MVT thing, so I'll keep it monolithic structure only. I also introduce incident embeddings and retrieving arguments workflows to improve operational context awareness. But that in the future we can evolve as much we want to do. I would add like we can add a semantic similarity search. We can add a search for the duplicate incident detections, background processing, operational analytics dashboard, vector search, kind of things we can integrate into the future as well. So as for this challenge and as the things I showed you, the overall goal to design this is to show the ability, for the architecture perspective, for the design perspective, I can help and I can design a better a good solution which can be scalable, extensible, maintainable, and uh, it use the all the industry standards, and it use basically it use what determine we can say uh, a reliable solution. Overall, my goal was to design a production oriented AI assistant operational support platform that balance rapid delivery with maintainable architecture, extensibility, operational reliability, scalability, and all the stuffs. So that's all about the presentation I want to show you. Thank you for your time, and I think that's what I want to show you. I'll share this with you for your review. Thank you everyone.